Hey everybody, it's Ron with Ron's Computer Videos. I want to thank you for taking time out of your afternoon and spending it here with us. As always, a wonderful interview, a very special Macintosh interview. So let's get right in it. He's an engineer, he's a programmer, one of the coolest guys in the vintage computing hobby, Mr. Mike Neal. Mike, how are you today?
I'm very good, thank you.
Well, I asked in the pre-interview. I wanted to make sure that was not too embarrassing of an introduction. So I appreciate your good humor, sir.
Appreciate that.
Excellent. Well, I know that from all your involvement on Facebook groups and things like that and different projects, and I follow you on various social media platforms, so I kind of stay on top of projects and things you're working on and neat stuff. And occasionally you'll share a really cool story about all of your work history and just different cool people that you've worked with over the years. But let's just start at the very, very beginning. Okay. What were some of the first computers that you used when you were a youth, and what was your very first Apple computer?
Oh, okay, those are great. Yeah, I grew up in Michigan, and when I was going to middle school, boy, this is a long time ago. We got the first computer in our school, and it was a Commodore PET. And I think the state bought them, like one for every school or something like that. I don't know exactly what the program was, but they had it. And of course it was locked up in a room in the back of the library. And so nobody used it. It just sat in there. And one day I was in the library and I asked, I'm like, I see you have a Commodore PET. I'd seen a magazine article or something about it. And they're like, you know what this is? And then I'm like, well, kinda. And so I started to use it, and they let me come in and, and try it out. And I, bought some magazines that had printed out basic programs, and I started to kind of learn BASIC. And so, that was my first real, one-on-one use of a computer and learning to program. And so that got me started down the path. And, my dad worked for Upjohn, which is a pharmaceutical company. And so research scientist, and he encouraged me to, explore that more. And one birthday, I got a VIC-20. And so that was sort of my first machine at home. That lasted a fairly short period of time. I kind of outgrew it pretty quickly and ended up getting an Apple II Plus. And so my Apple II Plus was my first machine, and that kind of really through most of high school, I used it. Interesting thing, I'm dyslexic. And so one of the things that the Apple II was great for me was I had a hard time writing, and being able to use a word processor for the first time and print things out on a printer was a huge benefit for me. And so, that really, really helped. And of course, I played a game or two, so. But learn how to do more programming on it. First, I wouldn't say commercial because I don't think I made any money on it, but the first sort of program I wrote for somebody else was a set of basic programs. I was on the swim team, and so one of the things that they had to do when you had a swim meet was you had to do this thing called circle seating, where they assign the lanes based on the qualifying times for the people, and it was this manual process where they sit there and try to figure out who's got the faster time, etc. And then they'd print up the rosters, and that would be the plan for that swim meet. And so I wrote a program that did that. And so you could just put in all the times, and it would do all the sorting, and then set people into the right lanes, and then print out the results and final sheets for both the meet and then when the meet was over. So that was my first programming project, if you will. So
that's pretty awesome. I like those schools, or I'm sorry, I like the school or the stories where people that got sort of access to computing through schools were able to give back in a way.
Yeah.
I know that kind of in my computing career and things like that, I've always worked in education. I work in higher education currently. So it's always really, really neat to hear stories where people have, that it's like, I talked to the librarian, or I was able to get in with the AV manager and get time on the one PC or the one Mac that we had in those, and then be able to do a neat thing for that institution.
And it was great. In high school, I had a computer teacher. His name was Don Pinkham, and he was great. We actually started a computer club. I think there was probably 6 or 8 of us or something like that. But it was both learning about computing from programming perspective, but also he had an electronics background, and so we started to do electronics projects, and so I got to learn a little bit more about how they worked. And we built one of those Hero Heathkit robots. And that was the first time I really got into sort of machine programming, because that thing, you had like a hexadecimal keypad, and that was how you entered your program. So that was fun.
Yeah, it's nice to have mentors and people that actually care, that want to influence. And I know that there's so much stuff these days with STEM education and entire funded programs at public schools and things to try to get more and more kids excited about technology and programming and all of this. But back in the day, that was such a rare thing. You just happen to have to have like the exact right nerd librarian teacher who was also like, oh yeah, I bring my Commodore 64 in on, to play around with like, Disc of the Month Club stuff. Do you want to check it out? So.
Yeah, that's cool. Yeah, it's amazing. I have a good friend from college who mentors for the local robotics team. And to see what those kids are doing at the sort of same age that I was, and what tools they have, and all the equipment and programming knowledge, et cetera, that's available to them. It's just amazing to see what they can do, given all of those capabilities. So. Yeah.
Well, they have definitely got a leg up on kind of our generation, and just in terms of
back in my day,
right? Yeah, exactly. Back in my day, they hooked a light bulb up to a battery and said, "This concludes your 6-week course."
Exactly. Cool.
But after kind of high school and things like that, you ended up attending the University of Michigan, Ann Arbor. You were going for a computer engineering, computer science kind of degree. But you've got a really, really interesting story. And I think that that's one of those things that college is very important. It's very preparatory for the career and the world you want to get into, but not all the learning takes place in the classroom.
Yeah.
Do you maybe want to tell us a little bit about that?
Sure. Yeah, no, I went to the University of Michigan, was admitted to engineering college, and they had a program called computer engineering, which was a combination of electrical engineering and computer science. So you took classes in both. And I'll tell some, like, maybe the not so good part, and then the good part at the end. But one of the things was my high school didn't have advanced placement courses. And so I'd taken a bunch of programming and science classes, math classes that I really didn't get any credit for when I went to the university. And so I had to retake a lot of those. And so that kind of, when I kind of got there and had to take these classes over again, it was a little, this is this is kind of a pain. And so, I think, long story short, I started to seek out other opportunities when I was at the university, because I was kind of stuck in this, sort of Groundhog Day of repeating, physics and math and things like that I'd taken. And so I met a guy, it's a fun little story. I met a guy in my first computing class, and it was, you could take the CS 101 in either Pascal or Fortran at the time. And so I took Pascal because I knew Pascal, and turns out I think I knew more than the TA who was teaching the class, because he kind of got annoyed with me when I was correcting him from time to time. And he's like, "You obviously know this material. You really don't need to show up." And so, but the first class, I met this guy, Tom Conrad, sitting next to me. And Tom came to me one day and he's like, hey, there's this engineering college group called CAEN. It was the Computer Aided Engineering Network. And they ran all the labs with all the computers in it, both, you know, things like Macs and PCs and that kind of stuff. And then they also ran all the, we had a big Apollo workstation and DEX and, you know, Unix systems and all that kind of stuff as well. And he's like, I'm going to go up and interview for a job being one of the lab monitors. And it turns out, you know, as a student, you could get a job, you've worked in the lab, and, you know, if somebody had problems, they come and ask you questions, or, you know, if the printer jammed or whatever, you know, you do that kind of stuff. So I'm like, okay, I'll go with you. And so we went up to this building on the North Campus of University of Michigan, and he went for his interview, and I was wandering around kind of, you know, waiting to see what's going on. And I walked into this lab, and there was all of these machines I'd never seen before. And it turned out it was the advanced visualization facility for the university. And it had Ardent Titans and big Apollo systems and Stellar GS1000 and all this kind of stuff. But they had a big Mac set up in there, and I had a Mac at that point in time. I was on my Mac 2 era. And and I was like asking him about it. And I'd worked at a print shop when I was in high school. And so I knew color printers and things like that. And the guy that was working there is like, you know about this? You know, like, and I'm like, yeah. And got, you know, a fair amount of experience with it. And he's like, I don't know. He was a Unix guy. He was like, I don't know anything about a Mac. I don't know how to make it work. All these professors come in and they need help working on it. You know, like, he's like, you want a job? And so Tom comes out of his interview and he's like, I got a job. And I'm like, I think I got a job too. And so we both ended up working for CAEN. And it was a great time because it was mostly student, and there was a full-time staff, but the majority of the folks were students. And a bunch of the students that we worked together, we all, you know, we had this group, it was called the Mac Support Group. And, you know, we were the ones that, supported all the machines across the university. And we also got to do software development for it. So we would build, we built this thing called Launch Break that allowed us to have licenses that you could check in and out. And so we could take, you know, expensive products, and you could check out a copy of PageMaker and be able to run it on your Mac. And then when you check it back in, you know, we would stay within our compliance for licenses. But, you know, boy, a bunch of us ended up at Apple. So one of the things that was fun was the University of Michigan Ann Arbor hosted MacHack for quite a few years. And we would provide all the equipment. And so it was usually at a local Holiday Inn hotel. But they needed, you know, machines and all that kind of stuff. So us as students, we would schlep all the machines out there and set them up and take them out of some of the labs and do all the networking and all that kind of stuff. And this is back when you made thin net connectors. There was no, yeah. And so as a perk, we got to go to the conference. And so a bunch of us would go and attend the conference. And so MacHack was, you know, the first time I started to interact with people at Apple. And Scott Boyd and others would, Greg Marriott, et cetera, were, you know, there, who were hosting the MacHack conference and parts of it. And so we were, you know, getting an opportunity to kind of work directly with these people that worked, you know, at Apple and built the machines and wrote the software for it. And so that was a lot of fun. And I think, you know, kind of jumping towards the end of the conversation, you know, story, MacHack had the hack contest. And so the idea was, if you're not familiar with MacHack, it was a strange conference because it started at midnight. The keynote was at midnight, and it ran for 96 hours straight. And so there were sessions all day, all night, 96 hours. And it, you know, the hack contest was show up, come up with sort of a unique idea, write it or finish it, and submit it as as your hack for the hack contest. And the joke was always that it couldn't be useful. You know, that the idea was that it was just, you know, something fun. And so that year, last year, I actually had 2 hacks, but the one I submitted was called Ironman. And it was a little dongle that you could hook to the back of your Mac. And it used these little, it was a little decoder that Radio Shack sold, and, you know, a couple of wires and a phono jack, and plugged into the sound input port on the Mac. And on the Mac, I wrote a piece of software that would listen to the sound input port and decode the waveform from a IR remote control. And so you could use a little Sony remote control to control your Mac. You could play and pause QuickTime movies and eject the CD and, you know, all those kind of things. And I ran through the demo of it and, you know, did all these things. And then the last thing, I pushed the power button, and of course the machine turns off. And so I actually won that year. And so that was pretty cool. And
that is pretty amazing.
Yeah, that was a lot of fun. And you get this, it's a Victor A-trap, A-trap being a Mac term, but it was actually a rat trap, like a big mechanical rat trap. And they'd scratched out the R and the T, and that was the A-trap. And that was your award. But the other thing you got was you got a interview with Apple. And so that actually is sort of path that I went down to end up getting an interview at Apple.
That's pretty amazing. I've heard a lot of stories, and there is a book that came out a number of years ago. It's called like Late Night at MacHack,
yep.
which my understanding is that some of it is kind of a sanitized version of maybe what really happened, you know, just to avoid offending people. But as someone who has read through that book several times, I always thought it was really this very magical sort of thing that to be involved with. So to actually go there and not just be able to participate, but also to win is a pretty big achievement.
Yeah, it was funny. Scott would go out and buy all the prizes, and you got the trap was the, you know, and they went to the local hardware store and bought a rat trap and scraped off the parts and wrote on the back of it, you know, but they'd always have a bunch of gag prizes. And I remember one year, I think I know who it was. I won't say who it was, but somebody got this prize, and it wasn't for first place. It was just like a you know, funny prize, and it was a frozen turkey. and so here you are in a hotel room in Ann Arbor, Michigan. You traveled there. What do you do with a frozen turkey? And so as a joke on top of the joke, he had it packed up in a you know, just a cardboard box, and he shipped it back to them. But like slow, you know, U.S. Post, as slow as you can go. And so this, you know, week-old frozen turkey that wasn't frozen anymore showed up on somebody's doorstep. So yeah, there were a lot of interesting times there. And of course, you know, after 96 hours, you're pretty tired.
Everybody's a little loopy after that. That's how a lot of those stories, that it's like everything started with the best intentions, exactly. But at hour 90, we didn't know what was right or wrong anymore.
Yeah. No, there's some wild.
There are a lot of really amazing projects that came out of that over the years, and a lot of like people that draw a lot of water in the community, and people that have written a lot of like very, very famous and kind of classic, you know, just again, like you said, fun things for the Mac. Like I remember like the Energizer Bunny and the train that would kind of come across, and you know, and then you would get that from like a friend of a friend of a friend that had a floppy, and then it would end up as a After Dark module one day. You know, it's just amazing, like all of the stuff that just these little things that people did that was just for fun, and how it ended up shaping a lot of people's experience with Macs back in the day.
Yeah, it's funny. You mentioned NetBunny, which was the little Energizer Bunny one, and that was Dean Yu's hack 1 year. Dean was one of my roommates in college. We both worked at CAEN, and Dean went on to work in the Blue Meanies at Apple. Steve Bollinger also was at that time. He went on to work at Apple, worked on iPod, a bunch of other stuff. Dave and Steve Falkenberg also there. Steve runs, what has he got? Safari and a bunch of other stuff at Apple. Dave's in hardware land. He does a lot of the power management and all that kind of stuff. Tom went on to do, well, he's CEO of Sonos now. He was in the Finer group for a long time. And, you know, it was just a great group of people. It was, you know, a confluence of time. Like, it was just one of these situations where, you know, Apple was supporting the university because we had so many Macs and we had so many machines. And so we got a lot of more sort of one-on-one time with them. And that grew a whole bunch of people who, you know, end up going to work there, which was a lot of fun.
I think Apple's investments in the education community and especially teacher outreach and helping, it's like, you know, there was a lot of equipment out there that like your story earlier, where it was like, you got a Commodore PET and then it ended up locked behind a cabinet, you know, locked behind a door somewhere, where people just didn't have access to those things. So it was nice that, especially like the Apple II and kind of things starting out, and that it was basically like, here's the software, here's the curriculum, here's how you integrate this into class time, where it's not just a games thing, it's like that, you know, number muncher, you know, it's Oregon Trail, it's all of these things that are like these educational experiences hidden in sort of, you know, made to look like a game. And then, you know, giving the support and the hardware and just the resources that educators need to be successful.
Yeah. There's a funny story. It just reminded me. It was the first. So, you know, I obviously got paid by the university to work at CAEN, and which was great. I actually took the job primarily because I hated the dorm food and I wanted to be able to eat out. And so it was enough spending money that I could, you know, get a sandwich from Zingerman's or whatever from time to time. But I decided to stay at the university one summer, and there was a group of folks that I met through MacHack who had their own consulting businesses or software development businesses in Ann Arbor. And so I got to know some of those folks. And there are people like Eric Shapiro and Bill Warzel, Dave Koziol, who all, I believe, all still live in Ann Arbor and you know, continue to do development work. Bill came to me and he's like, hey, I got this company out in the East Coast and they want to build a networking card, and they need somebody who can write a driver for a Mac. And they were going to build, and I'm like, you know, Ethernet card or whatever. They're like, that's kind of, you know, interesting, but there's lots of those. And they were going to build a 100 megabit FDDI card, fiber distributed data interface. And it was this like emerging standard that I think was mostly used in telecommunication or something like that. But it was dual counter-rotating fiber optics token rings. And so they're like, oh, we're going to build all the hardware, and the thing had like it had a more powerful processor on the card than was in the machine, type of situation. But their engineers are going to do all that. We just need somebody to write a TCP/IP driver for the Mac. And so we're like, sure, we'd love to do that. That sounds like a great project, summer project, and, you know, make some money and all that kind of stuff. And so Bill actually negotiated this turned out to be a sweetheart deal with them, which was they would pay us and there was a fixed price for it. And they would provide the hardware and all that kind of stuff. But if we ran into a problem that turned out to be a hardware issue, that they would pay us by the hour, because we were like, hey, you know, if we have to sit and debug your card for, you know, a week or whatever, I'll come back to that. We should probably get paid for that. And the funny thing is so we started doing this development, and there's kind of two funny little stories along this. So let me just hit on one of them. We didn't have any office space. We needed some space to put up a couple machines and connect them together and do all kinds of stuff and do the development work. And so Bill found this guy who had a barn that we could set up all our equipment in. And we invited the execs from this company out on the East Coast to come and check it out. And we told them, you know, come to the barn. And they were like, you know, our chickens and, you know, which in Michigan, quite possibly. But it turned out the company built church organs. And they were like one of the only, it was a handful of companies in the world that did this. And it was funny, I asked the guy one time, you know, how many of these do you build a year? And he's like, no, how many years does it take to build one? And he had this beautiful barn with like, it was all a big shop floor of all the, you know, woodworking equipment and all that kind of stuff. But he had a loft that was, you know, as nice as any office space I've ever been in. Like because all the cubicles were custom built woodworking, and you know, by somebody who builds church organs. So it was nice stuff. And so, and his deal was he let us use the barn, the loft, if we would help him with his computer problems. And so we were tech support for him, and we got free use of this space, and it was really spectacular. But
that's a good trade.
Yeah, it was a great trade. It worked out really, and it was a fun place to work. And so when we're working on this, we started running these problems, and we couldn't figure out what was going on. There's something wrong, and so we're like, we really think this is a hardware problem. Like we really think this is. And so they were like getting close to wanting to ship, and they were super nervous that it was going to slip, or you know, they weren't going to be able to get it done in time. And so they sent 2 of their engineers out to work with us on it, and we didn't have enough space at the barn at the time, and so they set up in the same hotel that MacHack was in, this Holiday Inn. And they got like a suite, and they set up all their equipment, and they had all these, you know, oscilloscopes and whatnot, and logic analyzers to try to figure out what was going on. And we spent, it was a long time. It was like, I think 3 or 4 weeks, and we were working, you know, as much as we possibly could. And these poor guys are, you know, away from their families and out in Ann Arbor. And it turned out it was a hardware bug, and it was a timing issue with NuBus and all that kind of stuff. And so we ended up getting paid by the hour at a crazy rate for those 4 weeks. So as a student, here I am, you know, thinking I'd have a nice little, you know, summer job, and I made a pretty good chunk of money. I was like, oh.
Yeah, it was like flush with cash. Yeah. I was ready to face any outward dining experience.
But and that was, you know, like the end of it was, you know, the MacHack thing happened, got the interview with Apple, and they ended up offering me a job. And I was looking at, you know, do I continue to take classes, or, you know, and I was basically junior senior boundary. Mm-hmm. And I'm like, you know, I think I'm going to go work for Apple. So that's kind of how I ended up going there.
Well, as someone here in the future, past Mike, this was a good choice. This was a good decision.
Yeah, it worked out okay. My mom was a little freaked out, but like, it'll be okay.
Oh, they worry. So it's like, don't worry, you can always go back to school. There's never, and that's the thing. There's lots of folks that had those opportunities where they saw that this is a big chance to go and do something amazing, or go and do something really exciting, and it'll be waiting for you when you get back. You can always finish up that degree. You might come back years later, like a lot of people, and be like, you know what, I started out, I was doing an engineering degree or something like that, but my career has taken me in this completely different direction. You know what, I'm gonna do a management marketing degree, because that's what, you know, it's what I'm interested in now, or whatever. So
yeah.
But I'm glad that you made kind of a bold choice to go and chase this. But when you did interview with Apple, I know that there's people, everybody has a different story about like the people that they interviewed with, or kind of what the tone or tenor kind of that interview was. But do you want to maybe tell us a little bit about the actual experience of interviewing with Apple? And was it one of those things they asked you weird questions, or was it basically just sort of a, like, we already have you hired, we just want to get to know you a little better?
Yeah, no, I definitely wasn't hired, and so it was a real interview. They flew me out, California, Cupertino, and my interview was in City Center, which is these big tall buildings. This is back before the either of the 2 big campuses were built, and so showed up, here's this kid from Michigan, and there's this, I don't know, 8-10 story tall building, middle of Silicon Valley. I'm kind of like, eyes as big as saucers, what am I doing here? Nervous as all get out. And so I went in and had the interview. And, most of it was pretty typical interview, I think, asking questions and getting to know me and all that kind of stuff. I remember there was one part that was unusual. I'm in the conference room and I'm just sitting there waiting for the next person to come in. And this guy walks in and he's got like bushy hair and he's kind of a little unkept and he's got like leather jacket and leather pants. He looks like, the leader of a bike gang or something. And I'm kind of like, oh, okay, who's this, right? And he walks in, he kind of looks at me, and he walks around the conference table, and he sits down on the floor on the other side of the conference table, and I can't see him. Like the conference table is now in the way, and so I can't really see him. And he's like sitting over there, and I'm like, okay, well, what do I do? Type of thing. So I sit there for a little bit because I figured I'd, let him say what he wants to say or ask me anything or whatever. And, so we sit there for, seemed like a long time. I'm sure it wasn't that long, but for somebody doing an interview, it was, felt like an eternity. And he started asking me, questions basically. And it was, from that point on, it was a pretty normal interview other than kind of the seating arrangement. And it turned out that was Jim Mensch. And so that was the first time I met him. And, so yeah, there's some characters that worked at Apple, but enormously smart group of people. I ended up getting the job. And I worked in DTS, Developer Technical Support. Started late in '92. And it was, some of the smartest people I worked with, but it was, somebody asked me once, like, actually, I think it was my mom asked me to describe my job. And I said, because she wasn't technology, that didn't really kind of understand the aspects of it. And I said, well, there are all these people who develop software for the Mac. And when they have a really hard problem, they work on it and they try to figure it out. But if they can't figure it out, they would ask us through DTS. And so we ended up with basically all the hardest problems. And it was a lot of fun because we got to go and figure out, answers for those really, really tough problems. And sometimes it was their bug, sometimes it was our bug, sometimes, it was new stuff that needed to be invented. And we did everything. I was in hardware DTS. So we did a little bit of hardware, so we'd try to figure things out if there were actually signaling issues, but a lot of it was low-level software. So it was, drivers and interfaces to the operating system and things like that. And so that was a lot of fun. But like Steve Falkenberg, who I'd known from University of Michigan, worked with me in the group. So that was, it was fun to have some of the people that I knew from. Dean was overworking the Blue Meanies. So, we kind of had this little Michigan cabal that all ended up at Apple and, various different groups. So it's fun to kind of continue to work with those people.
Absolutely. It's really cool. Again, that some of these, the people you meet at school, the people you meet through clubs and events and things like that, how that ends up shaping the people that you end up sometimes working with for an entire career. All of the amazing stuff that you worked on while you were at Apple through like DTS and with the PowerPC transition team and all of that. Jimmy Mensch is a trip. So yeah. I can only imagine some of the Jimmy stories that you have. But but do you want to maybe talk about like some of the other projects that you worked on internally at Apple? Yeah. I know that you've worked on a ton of stuff like Copland and with PowerPC transition team and some of these other hardware projects and just debugging other things that affect other teams. But
the PowerPC one's fun. Let me touch on it. So when I was there, I got there just before they started cutting down this path, but it was a big part of it was the transition from 68K to PowerPC. And they actually, PowerPC was one of the choices at the time. And they also built, was the 88,000 processor? It was from Motorola. They built, prototype boards that use that processor as well. And there's a guy by the name of Gary Davidian who wrote the original emulators for translating between 68K and PowerPC. And he wrote a K version first, and they actually packaged that board up in I think it was like a 2LC case, in little pizza box cases. Mm-hmm. And they brought it to MacHack, and they didn't tell anybody what was in it. And they said, can anybody figure out what processor is in this machine? And I think the only person that did was the guy by Steve Jazik, who had the debugger. It was there was MaxBug, and then there was the debugger, and it was, that one. And I think he was the one that he figured out that it wasn't a real 68K that was in it. There was some like weird edge case, debugging, dusty corner of the processor that he had figured out that tripped up Gary's emulator. But so that was, kind of interesting as, it was sort of the precursor to making the transition to PowerPC. So when they're doing the PowerPC project, this would be one of my contributions, I guess. Our day job was to help developers. So we were working with people like Adobe and Microsoft and a bunch of other folks get their applications ported native on the platform before we announced it. And so we're under NDA working with all these different companies to get their stuff ported over. And the compilers were rough, and the linker was rough, and there were a lot of tooling issues and stuff like that. So it was a lot of hand holding, and then also working with the OS team and the developer tools teams to get bugs fixed as they were developing those things. And when we were developing it, there was three machines. There was PDM, which was the 6100. There was a 7100. It was Carl Sagan, and got renamed. And then the 8100. And so that was sort of the lineage of the machines. And then they built this thing called STP. I forget what that stood for, but it was a NuBus card. Or no, it wasn't. It was a bus card that plugged right into the 68K bus in a Quadra 700 and 800, that kind of class of machine.
Yeah.
And it had a PowerPC on it, and it would turn your machine into a PowerPC machine. It was pretty cool. Yeah. And so they got the first ones of those into the hardware lab, and we went over to check them out, and they had it running. And we had this spirograph app that somebody had written that just drew a bunch of lines on the screen, and it was kind of the benchmark. And so it ran on 68K. There was a 68K version of it. They could run it on the 68K. They could run it in the emulator, and then there was a native version that ran on PowerPC. And of course, got faster as you got in a native version. And so they had it running on a PDM next to the STP, and it was running at roughly the same speed. And we're all scratching our heads. We're like, the PDM should be twice as fast. Like, it's got a 64-bit bus. The Quadro only has a 32-bit bus. Like, this doesn't make any sense. Like, why is this thing so fast, basically? Or turns out, why is the PDM so slow? So I went back and I was thinking about this, and it was bugging me. And I'd learned a lot about the PowerPC, and it turned out that video memory on these devices was marked non-cacheable. And so when QuickDraw was drawing, it used integer registers, which are 32 bits, to go and draw to the screen. And so every draw to the screen was a bus transaction. And so there was really only using 32 bits of the bus instead of the full 64-bit wide bus to go and draw to the display. The issue is you can't mark it cacheable because then you get artifacts on the screen because data would be in the cache and it wouldn't be in the memory that the video output circuitry was using. And so I came up with this technique of using the floating point registers to transfer the data to the screen. And they're 64-bit wide. And I wrote a little program to try this, and it ran twice as fast as doing it with just the integer registers. And so I wrote up I'm this kind of junior guy in DTS, and bunch of the QuickDraw guys were sort of the cream of the crop, and so I wrote up this long email with the code and a bunch of data and analysis, and sent it to these guys, and I get this note back, and they're like, "Holy crap! Like that actually works!" and so they ended up implementing it. They ended up taking my idea and implementing it as part of QuickDraw for the release. The issue was, and it was a bit of a controversy, it was late enough in the development that they'd already frozen the ROM images. And they'd been sent off to get mask ROMs. This is back when they actually used, physical ROMs. And so all that code was in ROM. And they could patch it. It was all set up so that you could patch it in software. So we had to burn, I can't remember, it was a couple hundred K or something like that of RAM, which in those days was a lot to get the QuickDraw updates. But Word, if you brought it up, one of the marketing demos was, here's Word running, and they would hit the scroll bar, and they'd have two documents, and you can see the 68K one go like that, and the PowerPC one would go, really fast.
Yeah.
That was me. That was all twice as fast because it was just bit blitz. So it was, that just it got quite a bit of performance. But I learned a lot about the PowerPC because and a few other folks, Jim Murphy, who wrote or worked on MaxBug. I don't think he wrote the original version, but he was the maintainer of it for the longest period of time. And Andy Nicholas were roommates of mine, and we knew a guy by the name of Dave Lyons, and Dave had started this project called Gus. And so it was Apple IIGS emulator for the PowerPC. And it was a great opportunity to both use the development tools and work out some of the bugs, like early versions of Code Warrior for PowerPC, and then also learn PowerPC assembly language, because we wrote some chunks of the core emulation in assembly. So that was a fun project.
Yeah, that's a really exciting time, because that was right about the era that I was finally able to buy real Macs. So I had a Quadra 610, and for a long time had a DOS card, and I was really, really pleased with that machine. But when the Apple PowerPC upgrade card for PDS, so the STP came out, I was like, yeah, I'm gonna join the revolution. And it's only clock doubled, so it's a 50 megahertz 60 or 601 rather. So nothing really to write home about. But I would say that as someone who at the time worked in retail, I worked for a company that sold a lot of Performa machines. So we sold that 6100, the Piltdown Man PDM. So we sold a lot of.
That was the joke, was the missing link between 68K and PowerPC. But
I can tell you that if I could put my upgraded machine next to the 6100, my upgraded machine was faster. It was cache and having like real VRAM and things like that. It made all the difference. So
the STP thing was a good solution, and it had a much larger cache. So it actually did outperform the main, the native machines, if you will.
Especially because the 6100 shipped without a cache module, so you're limited to just whatever's on die, I guess. But a 256K cache module really makes a big difference, kind of on those 6100s. If you could happen to find one, a 512 made for all of 3 minutes in 1994.
An incredible expense.
Yes, but I mean, to be able to then just move all your, to basically get your video and everything out of VRAM and into some sort of fast memory
made all the difference. So
Yeah.
but, I mean, that's why, you know, it was like the must-have upgrade was the high performance video card and all that type of stuff at the time. So I think that Apple was just kind of like, here's an entry level. You might not be somebody that is like a power user, but you want to have access to PowerPC native applications and things like that. So it made a lot of sense as just a inexpensive entry level machine.
I remember too. I think at the time, I know there was a big debate about shipping with or without the cache, and I think a big part of it was that it was super expensive, and it was in short supply. So I think they were worried about being able to get enough of it to, you know, because they were expecting the Power Macs to sell well, and they did, to have enough of those devices available. And so I think that might have been part of the reason was you know, wasn't that they wanted to derate the machine, but keep the cost down. And it was, you know, even at that time, I think difficult to get those parts. So
yeah, I think that most of them that I think that most of them that exist today, the cache modules that are in those lower end machines, all started life as cache modules that were in the server line, and those machines failed for whatever reason, and so those parts just kind of like made their way down to the low end. But yeah, it's I love that era. I mean, I know that a lot of people are like, oh, the NuBus era for Power Macintosh machines. What a weird time. And it was like, yeah, it was a super weird time, but like in the best way possible.
Yeah, and the Quadro is a great example. Was, you know, it was smart that they put this direct,
the
PDS,
interface
to it, because that, you know, opened up a whole bunch of possibilities, and there was no use for it from Apple at the time, and that STP was not in the, you know, nobody was thinking ahead to say, okay, this is coming. So it predated all of that stuff. But yeah,
it was nice. I mean, because, you know, FTP is so sort of like racing. It's like race fuel for your old 040 machine or whatever.
Right.
But Daystar, and I think
there were
remember who else, but
built their own.
Yeah, they built their own, but it was just like a flat 100 megahertz. So that was a really amazing. I mean, nobody can afford it. I only have the 2 kidneys. You know, I can't get one, but I mean, at the time, that was an amazing upgrade. 100 megahertz, you drop that in like a Quadra 650 or something. I think you end up losing access to one of your NuBus slots or something, but you could have a high-end graphics card. You could have 100 megabit Ethernet card, whatever you wanted to have.
I remember they used to have a really big, like, it was a lot of copper for that heatsink, and so like probably blocked one of the slots.
Yeah, I think like on the Quadra 700 especially, it's located. It's like an either or. So you would have to choose.
Oh, that's right.
Yeah, because then you're also, I think, limited to 7-inch cards or something. There was Apple.
It's okay. We probably come up with a different display connector for it anyhow. So
yeah, thanks. It's always something, but it's a lot of fun to look back on that stuff now, just because it was you did have to. There was a certain amount of institutional knowledge that people that were even just enthusiasts in those days kind of had to have, where it was like, okay, well, you could do this if this, but then not if you're going to do this. But if you're going to do that, just get this, and it's like. So, you know, to be able to help people that were, you know, the people that the grease monkey people that were like, you know, wanting to turn wrenches and stuff on those old machines. It was really a fun time.
Yeah.
So, but one of the projects you worked on when you were at Apple, you worked on the kind of the ill-fated Copland project.
Oh, yeah.
Which is a real shame, because I remember going to user group meetings and stuff, and there was a, gosh, at the time, you know, you would sit down and you would watch the 45-minute video of just everything new that was coming down the pipe, and people were so excited about like this kind of this next generation of the operating system, and for it to just to get so far along and then just to be like, nope. We're doing something different.
Yeah. Well, I can tell a good story on that one. So, we were doing the PowerPC work. And you know, at that point in time, Gary had written the emulator, and you know, it did a good job. It did a very good job. It was an amazing piece of work, and he was probably one of the better engineers I've ever met. But a lot of the operating system was still 68K. And so there's this push internally to say, okay, well, how, we've got the PowerPC in market. How do we like finish the job and build the native operating system for it? And so there was this sort of question of, should we go and port all of this 68K, and a lot of it was 68K assembly. Should we port all the 68K assembly to PowerPC, and maybe we port that to C code, or do we go directly to a PowerPC assembly? Well, that doesn't sound like a particularly good way to go. And so there was a lot of discussion and debate at that point in time. And well, my little QuickDraw thing had gotten me on the radar of the operating system team. And so they were like, hey, there's this DTS guy. We should get him to come over and help on this thing. And so I ended up moving over into the operating system team at the time. And so even before that, there was this project that was basically, could we take the OS, could we take all this 68K technology and port it to C so that we could compile it? And the project that got kicked off to go and do that was this one called Star Trek. And Star Trek was this small group of people. It turned out another one of my roommates from college, Fred Monroe, was part of that, and Fred Huxham. They went off with a group of folks to port the 68K OS to C, but they were going to do it to the Intel processor a long, long time ago. This was well before the Intel switch for Apple. And so it was this super secret, fly the pirate flag, send them off in their own building to go and do it. And they got it far enough along. It was a small group of folks, and it's one of these things, sliding pizzas under the door. Basically, they're working 24/7. I remember they got all the cool video games, like stand-up video games. But so they went off and did this, and they came back with a prototype. They got it to boot to the Finder, and so they had a C version of the OS, and so there was this big debate of do we use that? There was this question around the Intel path, and building a OS that could ship on PCs, Microsoft style PCs that could maybe disrupt Windows or whatever at that point in time. And I think smartly Apple decided that's probably not the right path to take. And so then there's this question of, okay, well, now we've got this C thing. Do we just compile that for PowerPC and ship that and have a PowerPC OS? And again, it was basically a direct translation of macOS at the time. And, that was getting pretty long in the tooth. And there were a lot of things in it that were, built around the limitations of the Mac hardware at that point in time. In 1984. And so that's kind of where Copland came from, was we're going to build a modern operating system. We're going to build the new version, it's sort of like the Windows NT, if you will, for the Mac. And there were a number of interesting projects that had been going on that were, some of them were research, some of them were sort of early development kind of stuff, but they all kind of got brought together. And so we had the new kernel team that was developing a core kernel. It was a pretty nice little kernel that ran multitasking, preemptive multitasking, which the Mac didn't have at the time. We had the toolbox team who was taking all this work that Star Trek had started with, and they're building a modern toolbox for windowing and menus and all the graphical user interface and all that kind of stuff. And then there was a file system team that had started working on a replacement for HFS, and they built this interesting file system. And so they started to try to put this all together to become Copland. And so there was there was actually a roadmap with Copland and Gershwin, and like they had there was a whole plan. And so my job at the time was this group that they formed called the integration team. And we were supposed to figure out how to take all these parts and put it together and build an operating system and be able to build that OS, and release it. Was ultimately the goal. And so we were kind of these jack of all trade people. There was a small group of us, and our job was to go and work with each one of these teams and sort of figure out how the parts were going to fit together, and then glue that all together, build the glue and the build systems and all that kind of stuff to go and build it. And it was a slog. And when I look back on it, there was sort of this classic problem, which was we had this concept that we called the blue box, and the blue box would run the old operating system. It was basically a virtual machine, but without sort of the VM kind of capabilities. And there was this big argument internally of whether the blue box and being able, this was sort of my experience looking at it, it was kind of like running Gus, where you ran the GSOS in a window, if you will. Would people, be okay with that? And there was a lot of push from marketing and executive teams to say, no, we want, I want to be able to launch Word, the old Word from PowerPC, and have that run natively in this environment. And so we were trying to keep legacy 68K applications and hybrid mixed mode applications working in this new environment. And to give you an idea, like, some of the crazy stuff there is, like, I can't remember if it was Word or PageMaker, one of those products, like, walked back in the stack. When you clicked on a menu, would walk back in the stack, change some variable in the stack that it knew was, this specific thing, so that when it returned back out, it would get the right result. None of that's, documented. How do you make that work?
Right.
The stack frames are all completely different because you're running completely different code. Like, we were chasing after this, kind of unwinnable problem. And so the other issue that we had is that all these teams were writing all this code, and they were just, heads down doing what they're doing, and none of them were working with each other. And so we ended up, that might be a little harsh, but we ended up being this choke point of doing the integration, and literally getting a build that could boot when we started a new cycle took weeks. And if you know anything about development, if you slow the development process down that much, you're the people who have checked in that code and they've moved on 2 weeks worth of work, and so there's thousands of lines of code further down the path, and they don't know what they did wrong back then, and what they have right now is not ready for prime time to be checked in and worked on. So we ended up in this really kind of harsh situation where everything was kind of grinding to a halt, and these sort of conflicting goals were creating a kind of unwinnable situation. And so they started this project, which I also got tapped for, which was maybe we should go buy an OS. And so there was a small group of us that met. Oh man, we spent way too much time in this conference room in the infinite loop. And our goal was to make a recommendation as to what we should do. And so we went and looked at Windows NT, we looked at Solaris, we looked at BeOS, we looked at Next. There's a bunch of other kind of random stuff. And I don't think this is necessarily a big secret or anything like that, but at the time, B was the most interesting new modern operating system at the time. And it felt like that was a good fit, like between the two companies. And so that was sort of our recommendation that went up. And infamously, Gil Emilio met with Steve, and Steve convinced him to buy Next, and so that's where they ended up. And it was interesting for me. Like, I put a lot of years and effort and time into Copland, and when that kind of came to an end, I was like, okay, it's probably time to do something different. And
I can see that being very frustrating.
Yeah, it was frustrating, but it was also, it was just, I also looked at it and said, like, this is an inflection point. and a good friend of mine, Eric Traut, who he was the person who wrote the dynamic recompilation emulator for PowerPC. And so he took what Gary did and he built this solution that was substantially faster. And so Eric had, probably the top developer I've ever met, like super brilliant guy. And he he had gone off, he'd left Apple because he had this idea of building an emulator that could do other things. And so I actually ended up following him to Connectix and went to work with him on Virtual PC. So
yeah, I was going to say, because it's because you've kind of hit on it a couple of times, but the virtualization and being able to sort of dynamically recompile for the hardware that you're on from this point forward is basically the big topic. Yeah. So I will say, because I knew that you had worked at Connectix and you'd worked on different projects there. For whatever reason in my head, I thought that you were part of like Game Station. I know that was not something that you worked on. But, yeah, but Virtual PC and all of that definitely was a game changer at the time, just because to be able to, especially at this weird time for Apple. Yeah. Where this was before Steve was there. Gil is like, let's just license our stuff to anybody that wants to make one of these machines. I was a big BeOS person. I was really like, if we're going to make something, if we're going to have to do something and we're sticking with PowerPC as a platform, I actually ran a BeOS user group back contemporary to all of this. And so. Yeah, all two of me. Actually, I think there was like three other people that would regularly come, and one of those person was on a PC, and they had a video card that was not compatible. I think they had a Matrox Millennium 2 or something like that, which did not have support in like the 3, like version 3 and all the little subversions of BeOS. But he actually wrote, and they sent him a ATI card with a little note from Jean-Louis that was basically like, hey, thanks for sticking it out. Enjoy a free video card.
I got an opportunity to meet him along the way, and he's a character.
Yes, that's been my understanding as well. So super interesting guy though, for sure. But but it does kind of underline how things can just go a completely different direction.
Yeah.
So. But Connectix and all your amazing projects there, Virtual PC especially, just the ability to, you always had the ability to exchange files and things like that, especially after getting to high density drives and with PC Exchange and all that software that Apple had published back in the day. But the idea of being able to actually, without additional hardware, being able to run x86 code was a pretty big deal, especially kind of as Windows 95 came on the scene and you started to blur the usability, usability gap between Macs and PCs.
Yeah, it was a fun project. It was, getting to work with Eric again. Was always fun. Like he's just a really great guy, and he was one of the. I learned something from him that followed me for a long time, which is take time to work on the tools because they'll pay off in dividends in the long term. And so Virtual PC, the version we shipped, nice user interface, all that kind of stuff. The one we used internally, we had all these debugging capabilities, we had scripting, we had memory views, we had all this stuff that we could build into the product that would help us figure out our bugs. And so one of the challenges here was you're taking the instruction stream from x86 and you're basically doing kind of a data flow analysis on it. And you can take that and build the basic blocks and then take that and compile it. And then you can collapse that and sort of optimize it to, say, hey, I didn't really need, this condition code or whatever. I don't need that. I can throw that away and optimize the code paths of the generated code. And that optimization takes time. So what we would do is you'd kind of compile to the dumb version, if you will, like just a simple translation. And if you ran that piece of code enough, then okay, now it's enough. You know, we run this enough that we should probably take the time to go and make the optimized version of it. And so we had this code cache that would, you know, build up optimized versions of the x86 code that you're translated x86 code that you're running. And so, you know, all of that, you know, would introduce potentially interesting bugs. And so having tools that could help us figure out, was that our bug? Was that somebody else's? You know, like how did you know, the system get to the state it is, was a big investment. And a funny little story on that, there was I might not be remembering the name of I thought the name of the game was Murder, Death, Kill, MDK. I don't know.
Yeah. Mm-hmm.
Was there
Shiny
MDK?
Entertainment. Yeah,
Shiny. Yeah, exactly. And so one of the things we wanted to do is make sure games ran well, because we knew, you know, the PC gaming market was much stronger than the Mac at the time, and so we wanted to make sure that you know, people's games worked. And so that game, for whatever reason, like when it was playing sound, it would screw up, and we'd hit, you know, either weird behavior or it'd crash. And so we spent a bunch of time trying to figure out why, because it, you know, worked fine on real hardware. And so we tracked it down, and it turned out there was a bug in their sound interrupt handling routine, a really obscure one. And you know, some piece of memory was getting dereferenced, and on real hardware it would be benign, but in the emulator, for whatever reason, we would, timing issues would cause it to you know, crash or have bad effects. And so we wrote up a bug report with, like, here's the code, you know, all disassembled, and here's the bug, and this is, you know, this is what you need to do to change it, and we sent it to them. And we got this email back, and they're like, how in the world did you find this? Because it's an interrupt handling routine, which is hard to debug. and like, do you have ICE or what? You know, in-circuit emulator? And we're like, kinda, because VirtualBC hadn't been announced yet. And they're like, we've had, you know, they ship, I don't know, zillions of these copies of this game. We've had intermittent bug reports from our users for the longest time that this is the bug. This is what was causing those issues. And the code is actually code that we licensed from somebody who did the sound routines for them. And so it wasn't even our code. And so we didn't know, you know, the code well. And so, you know, we know it. And so they sent us a like big box with t-shirts and coffee mugs and all that kind of stuff as kind of a thank you gift for finding their bug in their. That's
really nice. But you should have reminded them. You know, when I was in college, I got to charge hourly on this.
Yeah,
stuff.
exactly.
I don't know.
No, it was fun. That was good. Yeah, it was fun.
That's really good though. Yeah.
I ended up, you know, when we're a small team. It was four of us, or the core team, and you know, Eric did a lot of the dynamic compilation stuff, and Chad and, you know, those guys. I ended up doing a bunch of the networking. Was one of the first things I did. So, you know, it was emulate it was a DEC 21041 Ethernet controller. And so the reason it was picked was I found, you know, I think it was Alta Vista, probably not Google at that one time. I found the data sheet for it available on the net. And so, you know, all the registers and everything were documented, and there was a driver for it for Windows. So, you know, that's how I started doing networking for VirtualPC.
It's pretty amazing.
Yeah.
It's again, though, all of this was so foundational to where computing is today. All of this virtualization technology, and I mean, even small stuff today, like emulators and stuff for like the PC, where you can emulate and not like VirtualBox and things like that, but like community ones, where you're literally like, oh, it boots up and there's the BIOS from some compact machine from 40 years ago.
So you're like, register for register. You're able to emulate these machines for whatever purpose. It's games. It's games.
Yeah.
But it's. I mean, nobody's still like, oh, finally, Harvard graphics runs exactly the way it was always meant to.
Yeah. That's right. I didn't get in on the whole like making Fortran work for Y2K. So
it's fine. They're still working on that. It's just it's only affecting like the entire insurance and healthcare industry. It's fine. They'll figure it out. Yeah, they heard something about a Linux bug here in a couple of years. Oh, we'll get to it. It's on the list.
The list.
Yeah. But after working at Connectix, you left and created a startup that actually had, again, you can't get away from these people. These people are constantly needing you for projects and for, hey, like, we like this thing you're doing. We're going to acquire this thing. Do you want to talk a little bit about Pixo?
Sure. Yeah, sure. Okay. So we shipped like, I think it was probably, we're on to our third version of Virtual PC. And so I was kind of like, I'm kind of looking around, and I had met a guy by the name of Paul Mercer, and he worked at Apple. He worked on, one of the things, he worked on a bunch of stuff, but one of the things was Newton, and one of those kind of interesting Apple projects. Yeah. And another guy who I'd gone to University of Michigan with, Jeff Miller. Jeff's still at he just retired. Jeff just retired from Apple, but, just recently. But he, I think, last thing he was working on was Safari, and so Paul was like, "Hey, I'm starting a company, and I can't tell you a lot about it, but I got Jeff and this other guy, and we got an office and some money, and so would you be interested in come work on it with us? We're gonna build an operating system." And I'm like, okay, well, that sounds interesting. And so Paul recruited me, and the company initially was called Tacit Software, which I thought was a great name because it was benign, like we're just behind the scenes. But our goal was, and I still know the elevator pitch, we were building applications or operating systems and applications for mobile devices. And Paul's vision was to take, the Newton style of an operating system and the graphical user interface and those types of things, and bring that to mobile devices, in particular, targeting mobile phones. And this is the era well before iPhone. Where sort of the flip phone, candy bars from Nokia, that kind of thing, and programmability, like there was J2ME, which was this sort of weird Java for mobile devices, was just kind of becoming a thing. And so we set off to write an OS, and we wrote a nice little operating system. It layered, one of the things we learned very early on is all these guys had their own sort of RTOS, or really low-level operating system, around the radio stack and all the other, kind of capabilities within the device. So you kind of had to sit on top of that. We didn't build a user interface. We built what they call a man-machine interface, MMI. That was the terminology that was used in the phone industry at the time. Most of the phones were little, 4x20 character LCD text displays. And so we had some success. We had a good project with Samsung, we had Nokia, we worked with a bunch of folks, and we did a few other little small projects. And then unfortunately, the bubble burst, and all that business went away. All of those folks, we'd grown up, we were about 120 people. So it was, reasonably good size. We just closed a financing round, so we were in pretty good shape from that perspective. But all the work went away, and at that point in time, we had sort of two groups. We had a group that was doing the devices and the OS that ran on the devices and the UI and all the authoring environment for that stuff. And then on the other side, we had a server team that was building services that the telecommunication carriers could run in their environments. And at the time, magical things like ringtone downloading was, they had no idea how to do it. And so we had, capabilities to do that. And so, unfortunately the company, is after, how many years, a few years, kind of had to downsize, and we had to, lay people off, unfortunately. And it was a tough time. Like I wasn't super happy, and a lot going on. And so I decided I was going to kind of look around and see if there are other, jobs available at that point in time, kind of see the writing on the wall, if you will. And so I went, I was like, maybe I'll go back to Apple. And so I knew Jeff Robbin, who he was an intern at or early on when I was there, but he was one of the new kernel developers. And I knew Jeff, and Jeff had left Apple after Copland, and he developed an app called SoundJam,
which no one has heard of.
Nobody's ever heard of
the SoundJam.
Yeah. You might know it by another name, which would be iTunes. And so Apple had brought him back. I think he bought him his bought SoundJam, brought him back, and so he's like, "Hey, there's a project going on. I think you'd be perfect for it. You should come talk to this guy." And so I show up, and Jeff's there, and there's this other guy, Tony Fadell, and I knew Tony. He went to the University of Michigan as well. And I'm like, "Oh, hey guys," and they're like, "We can't tell you what this is. Like, it's super secret. We just can't tell you what this, like, you've got to trust me on this. It's going to be really cool." And I'm like, Tony's, claim to fame at that point in time was the Philips Nino. It was a little Windows CE embedded device. It was really nice. It was sort of the Palm Pilot competitor kind of thing at that point in time. It was a nice device. And I'm kind of like, you got the SoundJam iTunes guy, and you got the devices guy. You guys are building an MP3 player. It's got to be what it is. Let's take a rocket science to figure it out. And so I was thinking about it. I'm like, I was talking to Jeff around the time. It felt like Apple still had a lot of the problems that it had when I was there with Copland, and so not that much had changed. Do I really want to go back? Like all this kind of stuff. And I said, I tell you what, I'm going to come back in 2 weeks, and let's talk some more. And I want to bring one of our, it was actually one of our sales guys from Pixo, to talk to you a little bit about what we're doing. And because I don't think I want the job, but I want to work on this. I think we've got a solution for you. And so I went back and I wrote at Pixo, one of the things we could do, because we had layered our OS so we could run on top of different RTOSes, we could also run it on Mac OS, and you could run on Windows, and it just run in a little screen. And, so you had this, we called it the simulator. And we'd actually take a photo of like a phone and put it in the simulator window. And so, you could click on the buttons, and, it would run just like a device. And so I built this little simulator with a little device. There was a company called Scout that we worked with, and they had, this little handheld device. And so I used their skin for that. But it had a little rocker switch on the side, and, menu display with playlists and artists and songs and all that kind of stuff. And I actually wired it up so like it would actually play a song out the PC when you clicked on it. And I just used, kind of what the iTunes UI looked like. But one of the other features that we had in Pixo was we could do internationalization. And so we could do, you could do any font, you could do proportional fonts, you could do, kanji, whatever, and so I translated some of the menus, and so I had like a little settings menu with little languages and that kind of stuff. So it came in, we did the demo for them. I showed it, and like they just kept kind of looking at each other because I hit the nail too on the head, and they're trying to keep a straight face because they're like, not telling you what we're working on, and so I ran through the demo, and I did the localization piece. And come to find out, so long story short, we got the job. We want you to develop the UI using Pixo for the iPod. And talking to them later on, one of the reasons that they chose us was we could do localization, and because they wanted to ship it, worldwide. And the company they were working with was this company called Portal Player, and these guys were smart folks. They did the chip that was in the original iPod, and it was a ARM-based device, but it had some hardware to help decode MP3s. And they did all the MP3 decoding stuff and all the low-level OS stuff. And but they had no idea how to do UI. And so it was like the prototype, early prototypes had one of those 4-line, 20-character wide display on it. And that was, not going to cut it with Jobs. Right. And so they wanted to have a graphical user interface. And so we ended up doing this really fun project. There were 5 of us: me, Jeff Miller, Chris Wysocki, who's still at Apple. He works on iTunes for Windows, and we called them the Canadians, Derek and Mike, who I think they went on to Broadcom and other places. But there's a small group, and Apple was super secret about it. So they're like, you have to be sequestered. Well, it turns out we just laid off a bunch of people at Pixo, and so we had an entire floor of our building that was pretty much unoccupied. So we set up shop in there and went off and did this sort of last project, if you will. And it ended up shipping, as the OS and the UI for it. And there were a couple funny things. It took us longer to negotiate the contract than it did to write the software. and the reason is our business model at Pixo was relatively modest upfront license fee and then a per unit royalty. And Apple was adamant there was not going to be any per unit royalty. And we argued on that for the longest period of time. And that's one of those business decisions that when I look back, you're like, oh yeah, per unit royalty on the iPod would have been pretty nice.
Yeah, that's the foresight of being like, I'll take less to be the director, but I get a cut of all the toys and merchandise.
Exactly.
The George Lucas sort of empire building.
We ultimately caved on that. And then the other funny one was the contract, they wanted to do 2 devices. So they wanted the iPod or the music player, and because we didn't know what it was called at that point in time. And then they wanted a second device. And so we were trying to because the second device could be a set-top box and you'd sell 100,000 of them, or it could be a phone and you'd sell millions and millions of them. And so we're trying to get a bound around that. And we went round and round with them for a long time. And finally, I just asked the guy, the lawyer that we're working with, I'm like, do you know what the other device is? And he sat there for a second. He's like, no. And I'm like, okay, that we can work with. We thought they had some grand plan of, some other, named iPhone or whatever at that point. No.
So what's your backup on this? You guys get your hackles up for not having a second option. God.
Yep. So, but it was fun. It was a good project, and I remember because we had the simulator, we could do the vast majority of the work all on the Mac or PC, and so that's how we did a lot of the development. And then we would send builds over, and they would integrate them. And it was a little strange because Apple wanted us to send them the builds on Friday, and normally when you do those kind of things, you usually send them on Monday, because and
you got a week to take a look.
Yeah, exactly. Well, it turned out what they were doing was they were flashing a device and giving it to Steve for the weekend. And he would play with it on the weekend and write up all of his notes and send those back. And so we get these bug reports, and we noticed the pattern. It took a little while to figure it out, but when they said the user and they capitalized the T and the U that was code for Steve.
Yeah.
And so all those were Steve's feedback, and they always took those ones very seriously. Those ones got fixed. But one of the funnier ones was he didn't like the font. I can't remember what font they used to start with, and so we had the ability to change fonts, and so we built a different one. Let's try this or let's try that, and so we build ones with different fonts. And so finally we built one with a font menu that they could just go in and select, pick one, if you will. And we put Chicago in there, which was the original Mac font.
Yeah.
And that's what got selected. He liked that. And that's
I was going to say, that's so iconic. I can't imagine that not being the default.
It wasn't. It was one of the thin, non-ligature fonts. I don't remember what it was, but it had very modern.
It was San Francisco.
Wingbats. Yeah. So that was fun. So
no, that's really exciting. Yeah.
Yeah, and actually, it had a good final outcome, which was Apple ended up buying the OS from Pixo. After we shipped the first version, and a couple of people went, Chris and Jeff actually went to work for oh no, that's not true. Jeff went back to Connectix, but some of the folks ended up at Apple, and then Sun Microsystems, who at the time were building a lot of carrier hardware, ended up buying the services side of what we developed at Pixo, and that was the end of Pixo.
Still, if even if brief, a very foundational sort of endeavor that affected, touched a lot of other equipment that people still carry around in their pocket. You would not believe the community of people that are keeping those fifth and sixth generation iPods going these days.
I found this user group on Facebook that's all these people. It's a little like what I'm doing in the Apple II community, which is they're building all these modernizations, if you will. There's even somebody who built a whole OS that runs on it that replaces the Pixo OS.
Yeah.
Feel bad about that.
Yeah, it's everybody. Everybody thinks that they've got a better solution or something, but. Well, it's nuts. All this
you can't sync the devices anymore because they don't make iTunes anymore. So you got to run. Yeah. You have to run an old OS, an old Mac OS, to run an old version of iTunes to plug your old iPod into. Yeah. It's a little. Yeah. I must say I feel my age a little bit when a product that shipped hundreds of millions of devices has already gone through its cycle. It came out. It had its moment. It was a huge success, and it's gone now. They don't sell iPods anymore.
Yeah, it's kind of one of those things where it's like the line got blurred between phone and media device, and so they were like, people are already carrying a phone.
Yeah,
and I for like a brief period of time there were I think Sony with their Ericsson line, they had or Ericsson with a partnership in Sony, however that works, had a iTunes phone that you could synchronize your music and stuff kind of before that iPod. Talk about like a clunky, weird experience, but it was nice when it all got to the point. But then you were for a long time, you were carrying your, Razor, and then you were carrying maybe even an iPod Touch for a while. And it was like, if only these two things could be a thing. Yeah.
And, going back to people involved, Tony Fadell, obviously super great guy, kind of a rough around the edges sometimes, but, I shouldn't say, he's just focused and he's just going to drive, like he's going to make it happen. And so rubs people the wrong way sometimes, but the iPod wouldn't have happened. And he was instrumental in the iPhone. And then one of the guys that was working for us at Pixo, Andy Grignon, I don't know if you know Andy. If you need a X-rated channel to have him on, but he's got an eloquence about how he talks about things. but Andy's great, and he was one of the original iPhone software developers and did a lot of the original work there. So yeah, funny. You mentioned plugging devices in. There's a guy, Greg Simon, who worked for us at Pixo and worked with us on the iPod stuff, and he was a big car guy. He loved BMW, and BMW opened a research group in Palo Alto, and he got a job there. And it was like, holy grail, like, this is awesome. I'm going to work on, new entertainment and all that kind of stuff. And the first thing he did was he built an interface that would plug in where the CD changer went on a BMW, and you could plug your iPod into it. And so everybody loved that. Like, you could, have 1,000 songs, and, it's all solid state and all that kind of stuff. That was really cool. He got fired for it. It turned out, and fired, I think basically got kind of pushed down. It turned out that they built it, they sold it. They didn't think they were going to sell that many of them. They ended up selling a ton. Like, it became like the option. Like, everybody wanted that, right? Yeah. So sold a ton of them, and it turned out that they made like 10 times more on a CD changer than they did on this thing. Nobody bought the CD changer anymore.
Right.
So they lost all this money on it. And they kind of blame Greg for that. He's done
you gotta talk to the marketing guys. You gotta talk to the sales guys and make sure it's like, hey, this thing's amazing. However, we make all of our money off of selling this widget. Yeah. That's unfortunate.
Yeah.
How things have changed. That's
indeed.
for sure.
Yeah.
So, but you after everything sort of finished up with Apple and working at Pixo and all of that, you went back to Connectix for a while. You worked on developing Virtual Server, and then after that, you joined the Microsoft team for nearly 20 years.
Yeah.
Wow, that's
over the dark side.
Yeah, I certainly wouldn't say that, because they've changed so much, maybe, but and so many people have moved around, so it's not. It wouldn't be kind of that early 80s version of the company. And then especially with the projects that you worked on while you were there, again, like more virtualization, Hyper-V, Azure, all of these technologies that people use today. I'm sure people that will watch this episode are people that work in industries that every day. It's, instead of having an entire rack of hardware, it's now all down to one box, or it's something that exists in the cloud that then you are, basically for whatever that, like the database application, or just servers and application development environments and other secondary virtualization and all of that. It's nuts how this touches everything now.
Yeah, it is. It's pretty amazing kind of look back at it. And there is a direct path from virtual PC to virtual server, and virtual server was the thing that Microsoft got interested in. Mm-hmm. And so they ended up buying the company, and a bunch of us. Well, it was interesting because like the Mac group, because we still had virtual PC Mac, and Microsoft had a pretty good size Mac division that developed Office and all that kind of stuff. Yeah. And so those folks that were working on virtual PC Mac went to the Mac group. Turned out they were in the Bay Area, over Mountain View. And so those folks kind of moved over there. And then there was the group of us that worked on virtual server and that sort of core pieces. And we ended up all relocating to Redmond and working at the campus there. And so we were part of the core operating system team, and we developed virtual PC and virtual server for them. But they had the vision, that they wanted to build a hypervisor. And there was a lot of debate internally. It turned out, after we got there, we found out, kind of like what was going on behind the scenes, because there was a camp of folks that were taking an approach to say, okay, we should just make the kernel, the Windows kernel, do all of this stuff. And then there was a camp of folks that, no, that'd be hard, not hard in just a technical sense, but just a much more difficult problem from a security perspective and a bunch of other things. Building this new layer below all of that in the hypervisor, and then taking advantage of new hardware capabilities that were coming along, would be the way to go. And so that's where Hyper-V came about. Eric Traut was the core architect of that stuff. It was interesting. I made kind of a transition when the acquisition happened. Microsoft had this thing called a program manager, and we didn't have those at Connectix. I was a VP of engineering at the time, and but it kind of seemed important. The way that Microsoft worked internally, you had at the time dev, test, and PM, and so we needed somebody to be in that role, and so I decided I would take that role, and so I was what they called the group program manager for the virtualization team when I joined, and it was kind of a shift for me out of being sort of day-to-day write code kind of development into more of a how do we think about the product, the customer, the strategy, et cetera. And so as Hyper-V matured and it shipped as part of Windows Server, I moved over into the Windows Server division. So it was the Core OS division, there was the Windows Server division, and there was the client operating system team and the client's Windows XP, that kind of thing. Yeah. And so I went over and sort of helped shepherd Hyper-V out, because the server teams are all freaked out. Like, the SQL team's like, we're never going to support SQL running in a hypervisor. That's just impossible. Like, we always joked at Microsoft is there's two operating systems teams. There was the kernel team and there was the SQL team. They were kind of like, get everything out of the way, give us access to the disk, we'll take it from there. So, there was a lot of sort of even internal education, if you will. And then there were customer feedback. Man, I remember having arguments with the Exchange team forever. Like, they would not support Exchange running in a virtual machine, and even in our own. And so it's like, okay, come on, guys, and finally they had enough customers who were coming to them and saying, yeah, you got to do this. I have a funny story on this one. I think the statute of limitations probably run out on this. My first meeting with Bill and Steve, I was working for a gentleman by the name of Rob Short, a longtime Microsoft guy. He'd come over from DEC with the group that came with Cutler and all that crew, and running the Core OS group. And I asked, I'm like pretty freaked out. I'm like, I'm gonna have to present to Bill and Steve. Like, I've heard the stories. Do you have any advice for me? And Rob's like, thinks for a minute. He says, find out what the meeting is before yours, because you'll know what his mood is. I'm like, and so I'm thinking to myself, how is like the junior guy and the new to the company and the Core OS group going to find out what Bill's schedule is? That seems like it's state secrets, And that's what I learned, that it's actually the admins within the company that run the company. And so getting to know, I asked my admin, and she's like, oh yeah, I can call Nancy and she'll tell me. And so I find out. So it turns out the meeting that I was having was, we wanted to ask to support Linux officially in a VM, and to have Microsoft make the statement that Linux was supported running in Microsoft virtual machines. And at that point in time, this was the Linux is cancer, it was a pretty strong feeling inside the company about what that looked like. And so we had the meeting, and I got all this material together, and customer information, feedback, and market size and blah and all that stuff. And so we had the meeting, and we're all waiting. And Bill and Steve aren't there, and it's like, we're in the boardroom. It's I don't know, 20 minutes, 30 minutes into a hour-long meeting, and they're not there yet. And then he comes in, and he's mad, and he's like yelling, and they're like, big argument about something, and I'm just kind of sitting there. And so Bob Magula's guy who ran the server group, like, okay, Bill, this is important, but we really need your input on this. Can we focus on it? He kind of got Bill like, calm down, focus on this. Did the presentation. Kind of got to the end of it, and he was asking a lot of questions, like really, punching at us, and got to the end, and I said, look, there are people who are going to run Linux, and those people could run Linux in a VM on top of Windows, or they can run Linux in a VM on top of Linux or VMware at the time. Okay. And which would you like? And I think that was the thing that swayed him. And they ultimately said, yep, we're going to do that. And we did a whole bunch of work to go partner with Novell and, other folks, Red Hat and other people like that, which was, oil and water kind of situation at the time. But it turns out the meeting before mine was the one where he found out how big the fine was from the EU. It was like $500 million or something. So he was a little grumpy.
Understandable. So this seems, in retrospect, it just seems like, hey, here's a way that we can capture more, market, or, or you could just keep focusing on the fact that we're just going to have to strip Internet Explorer and Media Player out of our operating system.
Yeah, well, I mean, there's that, but I think the thing that there were a couple of things that Microsoft was very concerned about, which was the client business model is that you buy a machine and it comes with Windows. Like that was always the OEM business model. You could go to Fry's and buy a shrink wrap box, but not that many people actually did that. Like the majority of people buy their.
That's mostly a marketing endeavor. It's just
and upgrades and that kind of stuff. But enthusiasts and hobbyists and that kind of stuff. But for the most part, it's you buy a Dell and it comes with a copy of Windows, and they were worried about that with virtualization, that like that would decouple those things. And so now we're going to get in this weird situation where people are selling machines and then you're passing around VM images and doing and so there was that. And then on the server side, they were worried about okay, well now I can run 10 times as much stuff on one machine. Well, the licensing for the server was per machine. Like you paid, however many per proc, you paid a certain amount of money, and that, gave you the rights to run Windows Server on it. And so we spent a long time figuring out the licensing piece. I remember spending a Christmas in one of the conference rooms working through the details of it. And we ended up coming up with this licensing construct that actually ended up being a net positive from a revenue perspective. And it didn't matter whether it was us or Linux or VMware, like the licensing, applied equally across any virtualization solution. And so even when those platforms had success, Microsoft still had success for that. And it was a good option for the customer because basically our data center license was unlimited. And that was a big debate, like, processors, we're going to have 64 core processors coming sometime soon. They're 256 and above nowadays, right? So, it was a big debate as to whether that was, giving away the farm, but it turned out to be a good customer balance. The customer got a good value out of it. Microsoft got a good value out of it. So.
Yeah. It's nice. It's nice when it can kind of be balanced a little bit. It's I can't imagine. I do remember the time when you would literally see like on the licensing where it's like one, especially the Windows 2000 kind of era where it's like one or two processors, and you needed anything more than that, you were making a phone call because you were getting something that was kind of over what you would see in even like a home built kind of server, but.
And nowadays, I mean, I went on to work on Azure and lots of fun stories there, but we can maybe skip over that, or another day or something. But the AWS, Azure, Google Cloud, all the cloud services are built on virtualization. And even early on, we worked with Zen and ZenSource, who were the open source virtualization solution out there. We had partnerships with them to do virtualization layer, pair virtualization, all different kinds of capabilities there. And so and they benefited from the fact that they had a clear license, so there wasn't any ambiguity. These big enterprise customers are predominantly risk adverse, right? They just they're looking for what's the the old joke is there's nobody's getting fired for buying from IBM, right? It's
Right.
they look for a solution, and so that was a big part of it. Was it's cool technology, and there's everybody's a little worried about virtualization and performance impact and security and stability and all these kind of things, but really it was a huge cost saver for customers because they were able to consolidate large numbers of servers, and then it became cloud computing, which obviously is a huge part. And then of course one of the last things I did when I was at Microsoft Azure was a long period of that time, and a lot of fun and a lot of interesting things there. But the last thing was developing new hardware, and so we started a silicon team to develop custom silicon. And two things: one was compute, which was really based around ARM cores, and then the other was building AI solutions, and in particular looking at how do we make inference. Training costs were huge, and the training systems were these ginormous NVIDIA-based machines, multiple machine data centers of machines. But we knew we would need to be able to do inference, for the product, and so that was where we focused. Was how do we build silicon to make that less expensive. So, and
well, I just as someone who I started my career in higher education when we still had an IBM mainframe operation on campus. And then that was slowly replaced with, a million Linux boxes, and then Windows servers, and NetWare, and all of these things. I've been through all of these changes over the years, and it's been so weird to watch our op center go from hundreds of machines, literally, to 20.
Yeah. Yep.
It's, the what used to be a hearing protection required environment is now my Apple Watch will be like, hey bro, maybe walk outside for 5 minutes. It's it's certainly not the same world, but it's a wind tunnel, don't get me wrong, but it's a quieter one, that's for sure.
One of the funner things at Microsoft was every once in a while we get to go out and tour one of the data centers, and it was just part of I had the data center site selection team working for me for a while, and so you kind of, what are these things like? We gotta go take a look at it. And it was just amazing. Like, they're enormous, and they are hearing protection required, and generators the size of diesel locomotives, rows and rows of them, machine, zillions and zillions of machines, and weird things like, we take data security really seriously, and so once a hard drive comes into a data center, it never leaves. And so when the machines are decommissioned, all the drives are taken out and they get crushed on site. And so they had this machine that, I don't know, where do you buy like, it was this big mechanical device that they could put pallets of hard drives into, and they just turn them into dust. And interesting stuff. So
it is. Weirdest part is, where do you get the machine that you use to crush the hard drive crushing machine? I'm just saying, where does the security end?
Yeah, exactly.
I do remember though, having been to, I went to Southern Illinois University, and had toured some of their mainframe operations and things like that in the early 90s. And just a huge room and all the type of stuff. So I remember going and seeing Terminator 2 in theaters, and remembering that the least believable thing about the movie involving robots from the future was that people are running around this data center with no ear protection on, nothing. It is just like everybody, no one has fallen through a floor. No one has kicked the raised flooring up. I'm just like, come on, this took me totally out of the movie.
Yeah. Fun.
But 20 something years at Microsoft. And what was the first thing you did when you retired? You kicked your feet up.
I did.
And you were like, you know what? I should buy an Apple IIc. I should get back into
I took a little bit of a break, but it's interesting. Like, people ask me, I retired relatively young, I guess, in the grand scheme of things. But people ask
I
me.
mean, I'm going to take like a half day and then head over to my funeral. That's,
That's right.
you know.
And that was the thing for me. It's like people ask, or do you miss the work? And I say, yeah, I don't miss the work. I miss the people. Like there are a lot of folks that I worked with for, 20 plus years, or now 40 plus years I've known. And that was sort of the things that community and like, the engagement of that was something that I was kind of like, oh, I got to figure out how to scratch that itch. And I did a lot of stuff, family and friends and all that kind of stuff, and did some work, charities and boards and stuff. But
Nice.
I was like, you know what, I need something sort of technical and stimulating from that perspective. And I remembered back fondly to the Apple II era, and I never had a 2C, and I was like, I'd like to get one of those, just nostalgia, and I could play with it, and choplifter, and all that kind of stuff. And so I found the Facebook news group, the Apple II enthusiast group, and there's this guy Jonathan Eder on there, and he had a 2C he was selling. I'm like, okay, I'll get that. And so was it May?
Yeah, he's a real pusher on these Apple II machines. You got to be careful.
I know he's great, and we've become friends, and
he's a good guy.
He is a really good guy, and but he is an enabler. Like that's his thing. He's like
Yes.
You got this idea, and this guy's got this idea, and you two need to get together and work this, and you got to happen. Like, I'll send you machines, and I got one of those hard drives. So it's really great because he catalyzes the group to do good things. So.
Yes, he's one of those people. He's a team builder, and he's absolutely somebody that's like, I want you to be excited about the things that I'm excited about, and I very much respect that. He is. I've only been able to hang out with him in person just a couple of times ever, but I probably talk to him once every couple of weeks or something online, or he'll bring something up, or he'll send me something and be like, Ron, did you see this? And I'm like, oh wow, that's really cool.
I think Jonathan and we've been doing this for almost 2 years now or something like that. I think we talked on the phone for the first time a couple of weeks ago.
Oh yeah.
Yeah. so looking forward to meeting him face to face.
Yeah. Well, I know he goes to VCF events and things like that. So hopefully you guys can get together soon. But let's take a few minutes here at the end. Let's talk about some of your cool Apple II projects. I remember when you released the E2C DVI, and you've got another project, but do we want to start, like, what got you excited about making some of these new solutions? Kind of at the top of the interview, we did talk about that it's like people are getting back into this, especially post-pandemic, that it was like, we're going to do quality of life improvements for all these old machines. What got you excited about getting back into that too?
I have my Apple IIc back there, and it's it was fun. I wanted to program and do all these kind of things, but I've got a desk with big monitors and my Mac and PC and all that kind of stuff, and so I was like, there's got to be some way I can get the display. I love the little classic monochrome display, but Choplifter is much better in color, and like there must be a good way to get this on my big 4K monitor. And so I started on this project to basically do remote desktop for a 40-year-old Apple IIc, and so I got ESP32, which is a little microcontroller, and kind of figured out how to wire that up to the display port on the 2C, and it turns out the 2C has like this weird digital interface that was put together for the LCD, the classically seen on the beach scene in 2010.
Yes, classically in the nobody could see this. Plus,
nobody can see it. I think it was probably the only one that was ever sold. And so I built this little device, and so I was trying to do the remoting of the video, and so the ESP has a Wi-Fi interface, and so it can do Wi-Fi, and I hooked up the ESP32 over the network, a little application running on my machine, and did remote desktop. And so I could see, the video on my PC. And, got to thinking about it as I was working on it, like, there's not a good HDMI solution for, I didn't know about TangyPack at the time, but I didn't think there was a good HDMI solution for the 2C. There was A2 DVI, the card that went into,
Right.
2Es and 2GSs and all that kind of stuff. And so I thought, well, this seems like a little niche that I could maybe build a solution for. And so I learned how to decode and deal with the video output signals from the 2C. And so I was like, I'm going to design a new board that does all this stuff. And before I started on that path, I thought to myself, and this goes back to my MacHack days, I'm like, I've got a A2 DVI board, slot card. Is there some way I can interface that with the 2C? And I was thinking, you could build this thing so you could have a slot and a bus and all that. And then I finally figured out, it just reads the pins. I could rewrite the software on that device to read the pins that are plugged in to the pins coming out, the data signals coming out of the 2C. And so I built this little prototype that, basically had a slot in it, and it plugged into the back of the 2C and the new software. And so I was able to get HDMI video out of the 2C. And it was, crystal clear, everything looks great. And I posted about this, and Joshua Clark reached out to me, and he's like, I'll build a dedicated board. And, didn't know him, this is a part of the community aspect that I just love. It's like, here's somebody who just comes out of the woodwork and says, I know how to do that. I'll do the electronics design for you. And so he did the A2 CDVI, and the device that we came up with, I did the firmware for it. He did the device. And you've got a solution now for folks who didn't have HDMI. And you kind of asked me, like, what am I interested in this space? I take the approach is, I've done emulators, so I'm not going to do another emulator. I don't want to do that again. But I like the idea of how do you integrate these types of devices, these older devices, in the modern world. And getting a monitor is becoming more and more difficult. Nobody makes a CRT anymore, right? Right. And it's even hard to find a LCD panel that does NTSC or does it well. Mm-hmm. I'm doing poorly. And so that was, that's sort of my approach, is like, how do I take the machine and, make it more applicable or usable in a, modern context, modern solutions. And so that's kind of where I like to focus. So.
Yeah. Well, it's really neat. And it was very cool, because I remember when you released that it was just sort of like out of the blue. It was like, oh yeah, by the way, 2C, enjoy. And I was like, hey, this is really great. But like Rob with his the TangyPack and things like that. Yeah. It's an interesting solution. It uses that
FPGA,
the Tangy FPGA, to kind of do it. So it's this is a novel, sort of thing. But I mean, it shows that there's more than one way to skin a cat. There's more than one way is to kind of get to those solutions. And it's great that we've got multiple things out there, because it's better for the community, because part shortages happen. People sometimes lose interest, or we have a situation like right now where it's really, really expensive to get things made and then get it back into the US for hobbyists and things like that. So to have a couple of channels on those things, it only benefits the community.
Yeah, and I took the approach, I'm not trying to make it a business, if you will, right? And so, and so I at least take the approach, everything I'm trying to do, I'm going to do as open source. And and both from a software perspective, and typically with the people I've been working with on the hardware, they're willing to do that with their hardware designs as well. And so, because I benefited from that. Like I wrote a bunch of code for A2C DVI and new and novel stuff, but I built it on top of the A2 DVI code base, which was an open source project. And he built that on top of Ren's DVI for the Pico, right? There are a bunch of these sort of open source projects out there. It kind of goes back to my old integration role, is how do you take all those pieces and put them together and come up with something new and more capable. So, yeah.
Speaking of new and more capable, do you want to talk about the A2 Fusion?
I could talk. Well, I can. We have hardware. No, this is a kind of following down this path, and so going back to the slotted machines and sort of the, it's hard to find floppies. It's hard. I love a floppy. Like I like the sound. I like all that. Mechanical, but they're slow. There's all the issues that you have with them breaking, all that kind of stuff. So the idea is like, how do we take at least storage and video and bring that together as one device? And so you can have HDMI video and an SD card for your storage. There's a lot more to it than this, but like that's a good starting point of what the Fusion is. And the idea is that it's a multifunction device. And so, as we go along, we're going to add more and more pieces of functionality to it. So, things like a real-time clock and, mouse and, all these things. And there's solutions out there today. And so I don't, I'm not trying to poo-poo anything that's out there. I think there's great solutions out there. But it's nice if you're kind of new. I'm kind of new back into the Apple II world. You get a machine and doesn't have anything in it, going and tracking down either vintage cards or, more modern solutions, you're buying a whole bunch of different things. And so one thing I'm trying to do here is a little bit more of the iPhone, iPod kind of model is how do you bring that all together, have a nice user experience, so that you have a well-integrated device. And that's where we're early on. We do have hardware, but Raleigh is doing the hardware design. So that's really fun to work with him. He is amazingly good. And so he's charging ahead, and I'm trying to write a lot of software. So it's been fun.
It's very cool. I'm very excited because, again, I think we need more fun stuff like this in the community. Because having a couple of different options, again, there's always somebody that has like a very specific use case, like, hey, I want to do these 6 things and this device fills this need, or I have a couple of different machines that I want to be able to move things around. It's nice that this stuff is out there. So I was one of the people. I got to see your presentation last year at K-Fest.
That was my first K-Fest virtual.
Yeah. It was very informative. I'm really excited to see all the new stuff that you're working on and the continued success of these projects and stuff. Because again, it only aids the community to have learned and engaged people out there making things and not just making things, but then also releasing them back to the community for people to improve and to build on and stuff. So it just lives forever.
Yeah, and great example here is, Oliver has done a huge amount of work on A2 Pico, and there's a lot of that we're leveraging as part of this, and he's been working with us, and so I think there's this great opportunity to have a ecosystem, if you will, synergy. Like there's functionality that I'll do for A2 Fusion that has already shown up on A2 Retronet, which is one of the A2 Pico platforms. We did some performance enhancements, and Oliver's already taken those and reintegrated them back into those devices. So people who have a Pico with A2 Pico with and use Retronet can get a lot faster storage now.
Pretty amazing.
Yeah, fun.
Yeah. Mike Neal, thank you so much for your time today. This was really informative. It was nice to, especially for me, that I kind of knew a little bit of your history and everything like that. It was really great to kind of get like the real story and kind of straighten a few things out and hear about all the amazing projects and all the amazing people you've worked with, kind of in your time at Apple and Connectix and Microsoft. And it's this has been a treat.
Oh, appreciate it. And it was really fun to talk to you as well. So, and I enjoy all the videos that you do. So this will be fun.
Thank you, sir.
We might
That's
have to edit
very
this one down. I got a little long, didn't it?
No, this is great. Again, people love going down that rabbit hole.
All right. Sounds good.